Okay. Perfect. Okay, so let's get started the proper way. Welcome everybody. Welcome to All Around Azure. I'm Frank Boucher, your host. I'm a cloud advocate, and with me another cloud advocate, Maxime Rouiller. How about you introduce yourself, Maxime? What do you do?
What do I do? Besides standing in my basement and coding every day, I'm mostly doing what you're doing, which is advocating the cloud, advocating for developers, and mostly on students. And do not play with a gas camera again.
It happens. I keep it unlocked so I could fix it live.
Oh, we'll fix it later. But that's mostly what I do. So I talk and I chat about the things that I love the most, and it just happened to be Azure. And more specifically for me, I have a true love relationship with Durable Functions, which is a tool that I've started playing with, I think, since V1 and before it became GA for JavaScript. Like, it was only a C# tool before it became a Node tool, and now we're getting to this whole Python. So Durable Functions now is available in Python. And we're going to get onto like what is durable function, what is functions, and what is serverless, and what is the meaning of life. But it's going to have to wait a little bit, like for the last part. We're going to go through those in order.
Excellent. I'm very excited. And I was thinking about that stream, and I told you that earlier. I was like, yeah, that will be fun because you probably noticed because of our accent, but we are two French Canadian, and we're here talking to each other in English. So I thought it was fun.
Yeah, that is hilarious because literally I could take my car and in less than an hour I could get to your home if only I knew where you live.
That's a secret.
Yeah, but you have secret advantage. You do canoe and I don't. So you could probably go over water and I'm done. I cannot find you anymore.
Man, I don't know what happened. I think it's a NDI that depending on the connection is compressing or uncompressing your image or giving me different resolution. So
yeah,
sorry everybody. So along the talks I will play with Max camera to fit it in the so we can see him and not only just his nose or just a tiny bit of it. So should we start and share your desktop to see the plan?
Yeah, let's go with the plan first.
Okay, so let's switch scene. And your camera is not too bad in this one.
Awesome. Not too bad is good. All right. So the plan is we're going to go through the process just like any developers would do. I don't have an actual business problem to solve, but I do have a lot of things that I can try to do. So the first thing we're going to do is we're going to go through GitHub because GitHub has a public API and we can play with those and we don't have to be member of an organization to know like what is going on here. We can read labels of issues, we can count them, we can look at the dates and stuff like that. So we can start looking into those. So what I want to do is we're going to start with Azure Functions, right? We're going to start with the basics. Let's do this in Azure Functions, and we're going to start going through a little bit of code to see what we can do. And then we're going to start refactoring a function to something more durable, something that will allow us to orchestrate and go through those steps. But we're going to need to talk about a little bit what is Azure Durable Functions. And I do have the docs for that. So before we go further, let me just pull up the docs. This is Durable Functions. If you want to know what function is, you can go like Azure/Azure Functions. Like that's a short link for pretty much everything. And if we want to summarize real quickly, what is Azure Functions? It's basically a way for you to pay as little as possible.
Can I ask you to zoom your screen, maybe at 125 or something like that?
Let me just 150, or too big.
Could be me. I'm old.
Okay, let me just go to 125 because I feel like
usually 125 is good enough.
All right.
Thanks.
It does look good here. All right. So what is Azure Function, right? First, it's a serverless option, and let's not kid with this serverless thing. Haha, fun your servers. It's just a way to care about your servers less. I stole that from Jeff Holland, by the way, which is totally fine. And it basically allows us to plug in events that are happening, like, I don't know, messages that are coming in, HTTP requests, things like that. and run a code from that event and then output something. You don't have to output anything, but it's always nice to have some kind of result. So that is Azure Function, and they charge you every time you run, and they don't charge you for the possibility of like holding or reserving compute. You're not reserving compute at any time. So that's what Azure Function is. It allows you to go like in multiple languages, multiple functions, triggers, and blah blah blah. So I don't want to like spend like 2 hours on this.
No, anyway, and like if you are interested to talk about like the regular Azure Function, Thursday we have Brendan Minnick, who will come on this channel talk about Azure Function like the regular one in .NET. So
awesome.
That's perfect. So today we can focus on the durable one.
Exactly. All right, so let's get this rolling. So Azure Functions, that's our foundations. The serverless part, where every time there's a trigger, every time a trigger is activated, there's a piece of code that runs and something comes out of it. Let's just think of this like that. Those are small modules, small functions that all do this. But how do you like call one function to the next, right? I mean, that's kind of a problem, because if you start calling your own function, then let me just bring out Paint. Do I have Paint on my machine? I think I only have Paint 3D or something like that. So, come on, Windows, you can do it. I know you can do it. All right, Paint. So let's do a small drawing that's going to be awesome. So let's say you start your function here, drawing that's going to be awesome. It runs, and then you want to call another function, and this one is going to run, right? It does not end here. It will wait until the function here is resolved. It returns a result, and then processes a little bit more, and then this. But during that time, right here, you're pinged twice, because during this time here, this one is just waiting, and you're doing nothing. You're just waiting for something to return. And it gets even worse if you have multiple calls that are happening all at the same time, because now you're waiting for all of them to happen. And if they're sequential, one after the other, it becomes this massive line that just never ends. So we're going to solve that. We're going to solve that problem, because there are processes like that exist in this world that last longer than a few seconds. There's processes that last like for months or weeks or days, or like the smaller scale. I started on the wrong side. Right, like 90 seconds now. All right.
I didn't say anything.
Yeah, I know. I can read through mine at some point. Durable function is an extension.
Hurts, but I didn't say anything.
Got it. So durable function is an extension. Like that's amazing, right? That's the first phrase you see on that documentation, and it's true. Like, it's not a different product. It's an extension on top of Azure Functions. Azure Functions, by the way, is 100% open source, and the way that we support all those triggers, like for storage or Twilio or anything else really, is through extensions. They're all built through extension. And Durable Function is kind of like a very smart extension on top of it. It's an amazing piece of software that allows you to, at that point, create stateful workflows. It helps you to create those kind of things. So let me show you a little bit. Let's start first by creating some code. Right? Create a new project. We're going to go from scratch on this thing. Do not hesitate to interrupt me at any time, by the way.
Same for everybody in the chat. If you have a question,
we take questions.
Otherwise, Max.
Yeah. I won't stop talking.
Exactly. So please help me.
Please help. What should we call it? Yeah. Okay. GitHub.
Stream demo.
Oh, stream demo. Yeah, it's so original, man.
Stream demo 1.
It's amazing. All right. See demos. Do I have this folder? Does it exist?
Man, it's the first time I have so much trouble with the camera. I really don't know what it is, but it's, yep.
It's okay.
Yeah, I'm
You're
keeping
gonna survive.
adjusting. So sometimes you're going smaller, sometimes bigger.
People will be wondering what the hell's going on, but it's fine. All right, so I just created a project, but now I need to kind of start.
Trivia. We'll give away stickers if you want count the the correct amount of the time where the size change. No, never mind. Sorry. Continue.
So since I'm on a Windows machine, I could use something else here. I could use Azure, but I'm going to use the storage emulator that is already installed on my machine on Windows.
Oh, cool! I never use the emulator with the function. I always use like a real one, so that's nice. Yeah.
Yeah. So normally you don't need the emulator for functions, especially if you're running things like HTTP triggers. But by the fact that durable function is, I don't even know why it's not here. Right? It's not here.
Usually it is.
Yeah, it is. So what we're going to do is that we're going to go through all those and we're going to keep on adding some. So what I'm going to do here, I'm just going to start with an HTTP trigger, nothing complex, because that's what we want to do. We're going to start processing our GitHub issues. And if we go back to the plan, we decided on a repository that has quite a bit of issues. And by issues, I'm not saying problems. I'm saying that there's actual GitHub issues that are open on it. And it's the ASP.NET Core repositories with all the codes that are in it. And if we're looking at the issues here at the top, there's quite a bit. So we're going to go through all those and we're going to see if we can do anything about it. Make sense?
Yes.
Awesome. All right, let's just collapse that for now. Let's go back to the code. So, yeah, do not click on a window like that. So question for the chat then, because there's like almost 30 people. We need first we need more people. But two, anybody else has not used functions before, like at all? I'd love to know that.
Any serverless? Let's go like this.
Oh, yeah, let's go with serverless. Yeah, why not?
Serverless. If you have tried serverless, which flavor?
All right. So this thing is. You saw all the squigglies. It's just .NET restoring all the packages. Things are being restored. So now everything is supposed to be working. We can build a solution. I'm going to try to avoid keyboard shortcut, but yeah. So this whole thing now is currently building, as you can see here on the icon. This is processing. The build succeeded. It's at the bottom. It's very small. It's behind Frank's face, but it's fine.
I can't hide myself.
No, we're good, man.
Okay.
All right, so a little bit of code. Let me just zoom in because Frank is going blind. So we're gonna just start with that. Like, it's super simple. It's a piece of code that is not too complex, and we're gonna start with that. Just make sure that our Azure function runs. So it's gonna pop up this kind of screen where you can look at the top here. It says Azure Functions. There's CLI and func.exe. That is the CLI for Azure Functions, which is, by the way, also open source. We're going to see the version of the core tools that I'm running right now, the function runtime that's running, and we're going to get a whole bunch of different information running down that pipeline in a few seconds. The things that are currently being loaded is going to start detecting a few things. Like you're going to see here at the bottom, found the following functions: stream demo, that function one.run. That means it detected an HTTP trigger called function one. We can take that and we can go in the browser, say name equal Frank, and hello Frank, this HTTP triggered function executed successfully. Yay. So yay, congratulations. Now you can run that at scale on the cloud and scale to 100 servers. But it's not the fun part, right? Like all this code is like, could do better with that. So let's go on GitHub, right? We want to do more interesting stuff. So I'm going to stop this, and the first thing we need is to access GitHub is a package, because GitHub mostly is around. There's an API that you can access pretty much all the features of GitHub, and if you're just looking for GitHub, I don't know what it's going to return, but normally what you want is OctoKit. And it's right there. Is that the latest version? June 7, 2020. I would say yes.
So Brett Miller love function in the chat, and we have Morten MX who did the
nice.
Learn stuff. So we have a little bit of everything. So that's perfect. That's cool that we're ramping up slowly.
Yeah, we're ramping up slowly, but the thing is, at some point, things are going to get real. And if anybody else at any point has any questions, like do not hesitate.
It's definitely a safe place.
Oh yeah. I'm more of an educator than somebody that's going to judge you. You're not here for a job interview, and I cannot see your face, so you're all good.
If you didn't understand that, it was a friendly stream.
Yes, it is. I'm not going to upgrade that for now. I want to make sure we're not breaking anything. One of the things we're going to need at some point is the durable functions part, but we're not going to get that right now. So let me just describe what just happened, because let me just go into the project file. So I added a package called OctoKit, and that is all the package management in .NET is made with NuGet. And NuGet is just a package.
If you can zoom, that would be wonderful.
Isn't that zoom enough?
I'm that old.
Okay. So OctoKit has been installed. Here's the version. And behind the scenes, running something called NuGet, and NuGet is just the package manager for .NET. It's kind of the NPM for .NET. If you're like wondering what we're looking at right now, and compared to NPM though, like that version is locked. There's no like variable versioning. It's that the version you see here is the version that's going to be deployed, and even if there's a newer version, even if it's a minor version that fixes bug, it's not going to be deployed. It's this one. But on that note, we don't need to move further in that. And we have our function here. So the first thing we're going to do is let's rename this class here, which is weird. And we're going to call this stream GitHub sample. And here, normally, that's what it generates you. So let me give you a test. I'm going to, not a test, I'm going to give you a good tip. So what we're doing here is we're going to be scan issues, right? Mm-hmm. And normally I would have to rename this all the time. And if I change the name here, like to scan all issues, it does not follow, right? So here's a trick. I just did a Control-Z to undo my changes. I'm going to remove that, and I'm going to use name of. And I'm going to use scan issues, which refers to the function I just did, right? So now, if I do all issues, I'm going to get a compile time error now. Like this thing does not change. And if I rename the function by doing a Control-RR using a refactoring, I can do like scan all issues. And as you can see, this thing is following. So now you don't have any more problems with this thing. It just updates. So I highly recommend that part. What is expected? Oh, I'm missing parentheses. All right. So just a tip, just a trick, and we're going to keep on moving there. So let's just, first thing first, let's just remove all the code. This thing is fun, but not as fun. And we're going to create a few variables. So I know the organization is going to be called .NET. I know the repository I want to look at is ASP.NET Core. And this is coming from our plan that we have here. So let me just bring this thing here, right? github.com/.net/ASP.NET Core. We want to parse the issues, but we're going to need OctoKit to be there. So first, we can start typing OctoKit, and normally there should be a GitHub client that we can create. So I found it. I'm going to remove this initial part, and I'm going to do a small refactoring here. Control dot is your best friend. It's a contextual refactoring, and you do using OctoKit. And automatically at the top here, you see the namespace has been added, and our client now is available without anything else. So let's do a new, and a GitHub client, and now it's going to require a whole bunch of different stuff. So let me take a look at what is available. What's the properties? Yeah, so we need a product header value all the time, because this kind of thing is tricky. GitHub is very tricky, and if you don't have product header value, it's just not going to work. And version, we're going to call this 1.0. Stream GitHub bot. And do we have anything else? We're going to need our credentials. And let me just pull up the small changes here. What do we need? Credentials. So we're going to need... I think I can do product header value. And with the version, we're all good. And we're going to need the credentials to be new credentials. All right. Oops, did the wrong. And this one here is going to take a token, right? So we're going to need an object called token that we're going to need to define. There's multiple authentication type, but just having a token will normally work. So my token, pre-stream, I created a token, and it is in an environment variable. And to retrieve that, you would do environment.get environment variable, and I named it the GitHub streaming token. And I want to make sure that I'm using the whole process, and that's pretty much it. So credential here, why is it not working? Just looking at the code I was using. Oh, because it's not part of the... Let me just clarify that up a little bit. I'm going to clean up the code because it's going to be a little bit weird. But basically the GitHub client here is created, and then we're parsing credentials after. It's a weird way, I agree. But now we have a client that can connect to GitHub.
It's not that weird.
It's not that weird, right? But we're going to need to do a little bit of test on this. So let's see if we can get some requests in here.
We'll need
what can we do?
Scroll up. Otherwise, I will be able to grab your.
What? What am I not seeing? Oh, okay. I'm not in the screen. Okay. So normally I have the camera here and I know what I'm doing. All right. I'm going to try to keep stuff in the middle. So you can do a whole bunch of stuff. So the first thing we're going to do, just get, we can start looking at organization. We can start looking at repository, and there's one that's called get all for org. That's where we're going to go. So we're going to start with this get all the repository for an org, just as it's fun to see how it works. And we already have organization define, which is fun. And we're going to do a few API option here, because just want to make sure that I'm not retrieving all the private ones. And we do that. Get all public. Public repository request. And oh god, this is getting way complicated. So let me just clear this up, and we're going to filter them after. All right. If we look at this, there should be a task. So this is an awaitable version. So we're going to have to await this version. This is kind of the async thing of Azure Functions, or at least .NET. And we're going to wrap that up into a nice parentheses, and we're going to have access to all of our values. This is all the list of organization, and I want to do a small filtering on it by saying everything that is public or is not private. So let's see, repositories equal, and here we can return a value. So we're going to return all the repositories that are public in this. And let's see how it works, right? There is no possible way this is going to fail, right?
No. Brett Miller just started to learn C# last week, in fact.
Damn,
And
that's
now
good. It's awesome.
Now he's all about function and C# and everything. It's pretty cool.
Yeah, it is pretty cool. Do not miss what's going to come with C# 9. There's some cuckoo stuff in there. It's amazing stuff. All right. So by the way, as you're going to see here, our function has been found. Let me just scroll up the screen a little bit because apparently things are not being shown properly. You're going to see here, stream demo, stream GitHub samples, scan issues. Like this naming convention that we're using has already been reused now. We're seeing it live. And we're going to use this stuff here, scan issues. We know it's not going to return everything that we want yet. So we're going to just call it, and we're going to see what it returns. Let's give it a few seconds. And oh my God, so much stuff. So let me just zoom out a little bit because this thing is large, right? How long did it take to run? Like, I'm going small now. I know, Frank, you can't see anything. I'm sorry.
Right now, I just see hello, Frank.
Yeah, wait until this thing resolves. I'm looking at a Twitch stream to see if the video is going to be updating.
Oh boy.
Do you see it?
Oh, I see stuff.
Yeah. It's time to get your binoculars now. Like, those glasses not going to work. And look at the scroll bar on the right. I mean, it's even smaller. Like, this thing is like massive. We can keep on scrolling all the way down, and there's like so many repositories. That's because it is what .NET is. There's a ton of repositories in there. And that's not what we want to do. We don't want to scan all those. We want to scan the issues. But we know now that our API is working, that we have a token. Personal access token, by the way, can be created easily. If you're going to that page, github.com/settings/token, that will give you your personal access tokens, and there's going to be a whole bunch of them. My eyes, yeah. I love the commentary on the side. So the personal access token, you're going to be able to generate a new token, tell them like exactly what you want to do. When you generate a token, let's just create one just for now. Does not have to be anything. And it's going to give you something like this. I'm not going to keep it on screen. I'm going to delete it right away. But this code is what I put into our environment variable right here. So this was done pre-stream because I don't want to dox myself with an account and I have to reset the whole thing over and over again. But this token, once I'm done streaming this event, I can just delete it. So even if it's leaked during the event, there's nobody like in 3 months that's going to be able to take that token and run with it. So that's what we're using. And if you want to create any API in GitHub, and I cannot stress this enough, you have to set a product header value with a version, and you have to use a token. And here's the last tip. If you receive a 404 for anything that you do, there might be a problem with your permissions. Because if you see a 404 and it should not be a 404 because you're pretty sure the token worked before and that has not been revoked, and it's a problem with permissions. It's always that. GitHub is heavy on the 404. So now we get all of our org. We don't want to do all this, right? We want to get a specific repository in our case. So let's do get public repo. Get all no. I get a specific repository. Yeah, get. All right, so I can do a get. You can either go through the repository ID or you can do owner and name. And in this case, it's organization and repository. And in this scenario, we would get not a repositories, but we would have our single repo. Parentheses can be removed. Okay, we can do that. All right, so we have our repository, and it's already defined. We're going to do repository name here and refactor that here so we can return our repository. All right, so that is done. But now what we want to have, though, is all the issues, right? So let's see if we can infer that from here. Open issues count. And we can return that here instead. And why is it failing? Oh, it's still running. Sorry about that. I'm going to recompile the whole thing.
You didn't stop it?
Yeah, I did not stop it. So I'm going to I stopped it, and I'm going to repress the button here to restart it. And as soon as it starts, let me just close the token part here. We don't need it. So we see here that we have 2,369 issues that are opened. Let's hope there's, oh, they're actually working on it. So it's 65 now. And as soon as we're done, let me just reset the size here for our stuff to something that Frank is going to be able to see. And is it ready? So this thing is still starting. So we're going to give it a few seconds until it starts. So normally this application is all we're going to stay on. It's going to monitor your application to see like if there's anything happening. And it's going to refresh itself. So scan issues. And this time it should be super fast. 2451. And did they modify it again? Or maybe I had a different filter. Yeah, I think there's stuff here that is issue. And not a dot. 2451, because there are things that are not issues by themselves. There might be something else. But 2451 is the number we have and the number we have here. So we know we're on the right repository. We know we're getting the right stuff. So those are all the opened issues that we have. Let me see if we can do that and apply a filter for that, right? So client issues get all for repositories, and this time we're going to go and filter again with the same thing. So organization and repository name, and we can start applying more complex filters. So new repository issue request. Let me see what we can do here. We don't need initializers. So what properties can we do? Like I'm wondering. We have since, we have milestone, we have mentions, we have creators. What does this one allow us to do? All right, let's do something fun. We're going to pick one of the labels here, and we're going to look for anything that says, there's good issues that we can filter. I'm wondering if I can do a filter for anything older than a specific date. Have you done that before?
You did that before?
No, I'm asking if you did that before.
Oh, no.
All right. So
I didn't play with the GitHub API.
let me see if I can do something about this. So there's docs for OctoKit, and we're gonna see if we can do something like that. Get all for repository. So we could basically retrieve all the issues and filter them from now. See how it goes. Milestone, sign on, filter all. Filtering. Label, since. So those are not interesting. Okay, so we're gonna go with the all the issues in the last year, and we're gonna do a simple mat on it. So since we're gonna go daytime today, add year, and we're gonna add 1. We're gonna go -1. So this will allow us to retrieve all the items since the beginning. We're gonna get a count, and we're gonna be able to retrieve get all opened issues and kind of do a little bit of math from there.
Okay.
Does that sound good?
Yep.
All right. So once we have that, we have a count. Can do. And we're gonna do repository. That's not negative code, more complex than it need to be. So all issue count since last year. What count? And let's stop the debugger. So now we have an amount of issues that we have and that were open in the last year. And if we deduct that from the total amount, we basically have everything that is older than a year, right? It might be blocked, it might be still in the work, it might be enhancement, it might be more stuff. So let's see if we can get this one running. So let's press F5. And by the way, we're still just in functions now, right? We're still just playing with the basic code. Yeah. So how are people hanging out?
They're very quiet.
They're so quiet. Yeah. I mean, no hype, no lightning bolt in the chat, no nothing like that.
Do we have a lightning bolt?
I don't know. Do we have a lightning bolt? We should have a lightning bolt. This is function, man. Do I have one? Let me see. Lightning. Hey, Mara. Or Mara.
I have a fire sword.
Let me see what that's gonna be. Yeah, that's gonna be the best one. Yeah, like let's do this one. I don't have. I'm gonna go Pika Pika. Okay, waiting to see durable functions. We're getting there. We just want to make sure that we have some code to work with because we had nothing, right? We started with absolutely nothing. So we had 2451 issues and we're deducting the amount of issues that were open since the last year. And let me see if that thing is running. By the way, if you go back to that screen, you will see a log of all the things that are happening. Like you see here that I did a call on API/scan issues, and you will see this thing start running. So is it working? We may have to start talking about our weekends. I'm half joking here.
This is how you know it's live.
Yeah, this thing is supposed to be fast, and I don't know what's going on. It might be GitHub that is a little bit slow.
Well, that's possible. We might be in trouble a little bit.
Yeah, I might. I'm breaking stuff all the time anyway. For COVID, all I do is code either for personal or for work. Yeah. I understand. I understand that part. All right.
Oh. That's cool, Bitcoder. There it is. You have it, your lightning bolt emoji.
Oh, awesome. There is a lightning bolt. Okay, so 233. So what we did was very inefficient, right? Because I think that we retrieved all the issues, 333 of them, and we deserialized the whole thing, and we just took the count and was like, all right, goodbye, we're good, right? So that's going to be perfect, because I want something that is not efficient. I want something that is a little bit crappy, and that is perfect, because now if I go, and let me just open up a private browser, because I don't want to show you all the private repositories that are on the .NET repository here, or .NET organization, because Microsoft employee, private repo, stuff like that. Let's not do that. All right, so I'm not signed in, and how many repos is there, right? I mean, there's a lot of them, and there's like 9 pages, and like there were our archived one, and there was a whole bunch of them, and it's like, oh my god, there was like so many of them. And how do you run that code on all those repositories, right? Well, I could do this good old thing where I do like var repositories equal await, and I do client that repository that get all for org, and I do organization, and
please don't run that.
No, not as is. I'm not as is. I'm going to go with the filter here, where it says, wait, I have a need for parentheses here.
Hey, Quanta.
There is private. Not is private, right? Because we want all the repositories that are not private. We just want to make sure that we're not returning everything, and we're going to return a list. And let me just stop the debugging for a sec, so I can get rid of the squigglies. And I could start going through that list and like do a for each. But now, as you can see, like I'm retrieving data, I'm awaiting on that data, and I'm waiting for all this stuff to happen, and it's single threaded. I can start multi-threading a little bit, but you're running on a consumption plan, so you're running on free hardware, well, free in quotes. It becomes complex, and it's not going to be that performant. You're going to be running in a sandbox anyway, and there's no actual real way to scale, because what if somebody else just asks you again? Well, you're going to get the same code running again in a different different partition, and it starts to become problematic. So I want to refactor that, and so what do we want to do? We're going to, again, I love plans, so this stuff here, I'm going to put it on pause for now. So what we're going to do is we're going to start a function, and this time we're going to be creating a brand new function. And by the way, now we're getting into durable, and we're going to define a name for it. So we're going to call this
Smoofy.
Oh yeah, let's go with Smoofy. Mr. Smoofy HTTP start.
Excellent.
There you go. Public static async task I action result.
I'm glad you're happy about that, Mr. Smoofy.
Yeah, the names on this thing is going to be like horrendous.
Like you want to be scrolled up. I think you want to clip that. You need to scroll up the code, Max.
Oops, sorry.
I'm hiding it.
Mr. Smoofy. And all right, so we're going to need an HTTP trigger here. And the HTTP trigger is always going to be bound to an HTTP request message. And as you can see, by the way, I'm writing those by myself because I kind of been doing functions for like so long that please send help that I don't need to remember most of those. So authorization level, auth level. Where are you? Here you go. And authorization level here is going to be anonymous because I don't really care, because this thing is going to be running locally anyway. Mr. Smoofy. And so we have an HTTP function. And one of the things that we need to add to this, let me just, and I'll just collapse this whole thing on the right. It's just taking so much space. Let me just clear this out. I'm going to need a durable client. And this, you're doing that and you're doing a control dot, there's a few things like that you can do. And here you see I can install the Dribble task. And we're going to do that for now. I have no clue if that's going to work from that point of view. We'll see that now and we'll debug it live. And the Dribble client is going to allow us to basically create this thing. So let's do an iDribble. I'm going to wait until the package is done. Otherwise, the IntelliSense is not going to work. iDribble orchestration client. I'm going to call it client. And as you can see, like, this is the same thing that we have as the HTTP trigger at the top, right? I mean, we can get more of those, but let me just make sure that this thing is properly formatted. Otherwise, it's not going to work.
Yep.
And here, like this.
And just to keep you in the time, Max, we are 50 minutes in.
50 minutes in. How much time do I have left?
40.
I have 40. Man, we don't have enough time. All right, let's do this. Let's do faster. Client dot. Watch out, man. This thing is going to go fast. So there's multiple things I can do here. And the thing I want to make sure is that I return an orchestration. And I want to create a check status response. And to do this, I will need the request that I just passed in and an instance ID. And to retrieve the instance ID, I will need to actually start an orchestration. And to do that, start new async, await an instance ID. At this point, I can do I can start my orchestration from here, and I can pass it parameters, but I don't want to pass him an ID. And we're gonna give it the a tuple for us to start working with. All right, okay. Let's create an orchestration real fast. Function name of. And we're going to need a new name, chat. New name. Public static async task. This one is not going to be returning things yet. And we call it awesome for now, so I can refactor it. Chat. What should I call it?
Bcoder.
Oh, Bcoder?
Yeah, BICODOR. Bcoder.
Yeah, Bcoder. There you go. And
he brought the super emote, so.
Oh, awesome. So I'm gonna add by Orchestrator at the end, by the way, because otherwise this thing is gonna mess me up. So we're gonna take this one here and we're gonna pass it here. We need parameters at some point. We're gonna send, and so we're gonna have something that will be our orchestrator. Just give it a few seconds. First thing we're going to need is our organization name, and we're going to call it. This one is going to be called .NET for now. It's going to be hard coded, but we could actually pass it on through the HTTP start parameters, just like we did earlier. But we're going to hard code it for now. And why do you do that? It's a tuple. Yeah. So no, this thing is valid. Can I please convert to iAction result? Sure.
Oh, it's BI, by the way, not BE.
Okay. Let's fix the response type. All right, let me just fix the casing as well. There you go. Better. Mr. Smoothie becomes famous. Yeah, Mr. Smoothie starts Orchestrator now. So we have our Orchestrator, and this thing is going to start an Orchestrator. So there's something specific and special about Orchestrator is that they need to be non-deterministic. So if you're going to use things like datetime.now here, this thing is not going to fly. It is going to work, but it's not going to fly. As in, this orchestrator may be resumed at any time, and the now needs to be always the same thing. So how do you do that? We kind of need to use the context. And in this scenario, we're going to be first we need to tag this function as a trigger or an orchestration. And we're going to have a durable orchestration context. It's going to call it context. And if you ever want to use a date, just do date time here, like the current OTC date time. Boom. Problem fixed. You don't have to do that. If you're going to generate random numbers, you need to call them into a child activities of an orchestration, which is called an activity. Otherwise, it's not going to work. Activities are going to be actually doing the whole jobs. The orchestration is just the chef of the whole cuisine. It's going to tell everyone what to do, when to be done, and it's going to make sure that everything is assembled at the end so that it can be served to the client. But it needs to be non-deterministic. The actual work, it's not the chef that's doing it, it's everyone under him. He's making sure that everything runs perfectly. So for us, we're going to have this code here, but that is going to be the template for our plan. So what do we want to do? Right? So first, get all repositories, then process all repositories, and then we want to return the result of all the repositories. That's what we want to do. And that's a good way to start thinking about this, because the orchestrator is not going to do the actual work. So first, we're going to need a list of repositories. And to call this, we're going to need context.call activity async. This will allow us to pass in a function name and some input and basically say, go for it. And in our case, we know that if we do context.get input, let me just move that away from here. We're going to need an organization name to work with that. So the first thing we're going to need is to define our organization name. And I'm going to use a parameter deconstruction here because I'm using tuples. So organization name, it's going to be a string. And I'm going to retrieve that like that. Is that working? C#? What do you think? Oops. I think it's too much for it. Am I going crazy here? Like that? Okay, I think we're gonna keep this even simpler, and we're just gonna pass in the organization here like that and make things simpler. I was trying to be smart or fancy and didn't work. All right, but any object will be serialized in the end. So it does not need to be something like super specific. So we have our organization name. This is going to be passed into our activities. And in this case, this one is going to be name of, and we're going to need a new names. We need a subscriber name here. So let's do get all repositories. Who do we have in the list after Mr. Smoothie?
I reset my screen so I don't see anymore. Like, use my name for now.
Okay, I have cache 12, 12, 1. Let's do this one, 12, 12, 1. And so we're gonna need an activity. And this activity now, how do you define it? Same thing that we did earlier.
Because I don't want people also to be worried if they ask something in the chat that will be used. So
all right. So we're gonna define activity trigger, and it's the same naming convention. It's going to be an activity context in this case.
Don't forget to scroll up.
Yeah, it's scrolling up automatically almost. So this code here will return our list of repositories. It's just that right now it's returning a task and it's not really fun. So let's do await, but now it does not know exactly what it's returning, right? So we need to be more specific. What are we going to be returning? And in this case, I'm pretty sure I want to return a list of all the repository name, right, of all the things that we want to have. So it's going to be a list of repository name, and for me, just a list of string. In list, control dot, come on. What am I doing wrong? Right? Am I going crazy here? Or is this thing not working? All right, collections. There you go. I'm working too fast for Visual Studio. So we have our list of repositories. Right now it's failing because we're not returning a list. But we can do so right away. So let's take the code that we had earlier where we can return all the repositories, and we're going to do that. And we're going to put it there, and we're going to return repositories. And this time we're going to select a value. It's very functional language thingy here we're doing. Come on, you can do it. Working with max speed. Oh God. Oh God. All right. So the first thing here, we need an organization name, and we still need our client, right? So what we're going to do is we're going to refactor this client here, and we're going to move it up in the ladder over here. And we're going to move the token as well because it's something that we want to have. So static token, static client, and we're going to assume this thing is going to work. But here, we still need the organization name when we're going to be starting it, right? It's being passed here. So the same property here can be used. It's the same contract in this case. The input is the same contract. And now we want to filter this out. So we just want to pick the name of the repository, and we're going to return a list, and it should work. So we have all of our repositories, and let's skip the process and just return our list of repositories. So return repositories, and we're going to need to fix the return type. When we start this, there's not going to be anything running at the moment because we still need to monitor this thing. And
Whoop. Max?
the reason why I retrieve our URL stuff. Yeah. Hello?
Yep, you're back.
You hear me?
Yep. I think you're asking a lot to your machine, so it was slowing down
Might
a
be.
little bit.
Yeah, it might be.
You're back.
I'm back. All right. Let's wait for this to finish loading and have something up. So what we're going to have here is first it's detected all of our amazing function. And we're going to use the Mr. Spoofy start. Right? And I'm going to go a little bit quick here. But the thing is, I'm going to be picking up the status URI for this thing. And the reason for this is as soon as this thing start running, what happened? Oh, it was not ready yet. All right, let's do it again. All right, status URI right here. I'm going to pick the whole URL and open it up into a different browser, a different tab. And you're going to see here at the top the status of the actual function that is running right now. So this thing here is always going to return that. Whether the orchestrator succeeds or fail or whatever happens, this thing is always going to show. And you're going to be able to send event, terminate the whole process. You want to purge the history of this function, or you just get the status like we're going to do. Like this is totally possible. And as you can see here, from that URI, the status, we're going to get like the runtime status here. We're going to get it's running. We see the input we were passed in. We're going to see the output it has, but it has not finished running. So let's refresh. Oh, see that? We have all the repositories now. Boom. But you see the runtime status here is completed. So what that means is you can start monitoring that URI for changes. Like in poll once in a while. And as soon as it reaches either a failed or a completed status, you know that you have something in the output. In our case, we have the list of all of our repositories. It's an actual array of all of our repositories, and we can start processing that. And so here's the thing. we're going to be processing those. And in our case, the orchestrator probably only started maybe twice. And we can look at that in the log and see like what happened, right? We can start looking at the log and we're going to see here, executed the orchestrator. It orchestrated, like executed bytecode orchestrator. It finished multiple times. And that's normal because it is kind of like trying to monitor and running this stuff all at the same time. And it's trying to make sure that, is this thing still alive? Do I need to return a result or not? And that's the important part. That's the reason why this code in the orchestrator need to be deterministic, because the orchestrator is going to get called multiple times. And if you're running weird stuff, it's going to get blown to bits at some point, because you're going to get this like Schrodinger's bug where you don't know what happened or when it happened because you're using like random values in the orchestrator. So in our case, we're seeing all the things that were happening, and we see that get all repositories was called. But we're going to do these things with the bug, but this time we're going to do it for all the repositories in all of .NET. Ready for that?
Yep.
Is everyone ready for that?
Yep.
I think we are.
Just by the way, we have a little bit of delay when you show up. The result for us took a very nice 10-second.
You want me to stop sharing the screen and share it again?
I'm just saying, like, we eventually saw it, but it took a while. Like, when you say BAM for us, like, nothing's changed, and then you are explaining what you were seeing, and then it show.
Okay.
So there's a delay, like, there's a discrepancy between your camera speed, let's say, and your screen speed.
Okay. Well, we're gonna keep it a little bit. But
nothing dramatic. Like we trust that, and that's exactly what I'm typing right now in the chat, just explaining. So I won't say it. I won't write it. I will say it. Max is running everything locally right now and streaming and everything from one laptop. So even if it's a good machine, it's a lot of stuff to do at the same time. So that's probably why we have some kind of delay when he's showing things.
Perfect. Get opened. Get older issues. We're gonna call it that way. And by the way, if you're using the refactoring tool from the main code, you can just, let me just stop that for now. You can just do Control-R, and you can just rename it, and all the things get changed automatically, and it's magical. So this is the code we're going to be using to return the same thing we were doing earlier, right? See like how many open issues we have. So the same function we had above here, we're going to be running this code again, this thing here. So I'm going to be doing a little copy paste and refactoring it a little bit. So the client is still there. We're still going to need the repository at some point for the open issue count. We're going to need the organization name and the repository name and a whole bunch of different stuff that we want to measure. So what are we going to be doing here? So let's do await client, and I think we can do all this with just the actual repository. So let's just take this piece of code and go down again. The only thing we need now is the organization name and the repository name. So I'm going to try to do this all construction thing again. We'll see how it works. So repository name. And we're going to do that from the context.get input. And this time we're going to go with, I think it should be string organization name and string repository name. I think that should work. If my C# is up to snuff. It does. Awesome. Yeah, so basically that allows you to do what we call a named tuples and basically create kind of an object on the fly, because we don't need to create a different class and like start tracking those classes, and I really don't want to do that. And here, I don't want to return an object result. I just want to return the actual numbers. And as you can see here, yes, I am using today, because an activity trigger can use the time. It's just the Orchestrator that should not be using the time. And if you want to be even more strict about it, I think the context here has it as well. Does it? No, it does not. So only the orchestration context has this property, but you can use today, because at the moment it starts running is that moment that data is going to be done. And activity triggers, once it completes, whether it's success or failure, it's only going to run once. Well, at most 1 or 2 times, but it's never going to be running like multiple times every time the orchestration trigger starts. So let's take a look at this. So we have our numbers, everything is returning for all the organizations, and now we need to process those, right? So we're going to go through all of our repository in our repositories, and we're going to need to do a call to our context. Call activity async, name of, and get older issues. There you go. And we still need to pass in our tuple. So we're going to need the organization name. That's fine. And we're going to need the repository name. And this one can be done with repository.name. Right. What is the type here? It's a string, so we don't even need it. We're good. All of our repositories were string. And by the way, if you're confused about this, you can do control dot and say explicit, and it's good. Same thing for here, and we could go explicit. So it's easier. So here's the thing. If we're doing await, it's going to do those repositories sequentially, one at a time, and it's going to take forever. But we're serverless. We can scale to the world. So let's do this. We're going to create a list of tasks, and we're going to call those outputs. So let's do a new list of tasks. And instead of waiting, we're going to take the outputs, and we're going to add those all together. What's happening? What's that?
I'm laughing. Talk to me, Gooseman is.
Oh, he's doing wild. All right. Yeah. Okay. So
I know you don't like me doing that, Max, but 20 minutes.
Okay, we're going to be done in 20 minutes. Cool. The code might not finish.
We can bust today. There's nobody after us, but you know, I prefer being respectful of everybody's time. So
here's the thing: we're going to do a task.winAll, and we're going to pass in all the lists that we had. So that means that we're going to wait. Let's do await task.winAll. That when all of those tasks have finished running, only then and only then will we return all of this. And what I'm going to do, I'm going to go in the outputs, and I'm expecting a few of those to fail. So what I'm going to do is I'm going to be taking those that has not faulted, and I'm going to do a sum of them. Is that going to work? What's the type of X? X dot result. Where's the result?
Oops.
Oh, it's a task of int. That would help. Right, we're returning a task of int here, so we kind of need this to be returned properly, and this returns an int. So that will allow me to do result, right? Sum of the projected value. I need to fix the output, I guess. Say, why is it not working? Can I come over type to list of string? Yeah, it's not. Okay, so we're going to be returning int. All right, so we're going to be starting that, and we're going to keep an eye on our debug console. Is the debug console on, by the way? You see this? It's taking a while. So let me put things on a side by side, and So Mr. Smoofy is going to start this whole process. Things are going to be on the right here, and we're going to split the screen in two. Are we ready to see if this thing works?
Should have some sound effects.
Yeah, right.
I have a bunch of them for my usual channel, but not here.
I don't have anything for. We don't have the same swag as C# Fritz. Like his sound effects is out of this world.
I've been collecting them for a little while.
All right. So,
but
by the way,
on my channel, he did recently previously on Frank's channel. So
it's great.
Yeah.
So, by the way, so everything we're doing is we're just taking into account of all the opened issues that were a year older on all the repositories. So that means nothing, but all this code can basically be put like all together in the same in a different bucket in your brain. Like just do what I did here and just return result that makes sense to you. Like what about all issues that have specific labels? What about issues that have a specific label that have not been treated in X amount of months? What do you want to do with them? I just want to count them, but you want to store them. You can put them into SQL. And the thing is, if you were to save them, and we're serverless here, the save to repositories could be like a SQL database, and you would just do a single call. So there's no limit really, because you're not going to be spamming this database with calls. You're only going to be running this once. So I think we're good. We're ready to start. Let's do a refresh, and I'm going to get the status URI again, just so that we can monitor it at the side. And this thing is going to go wild, by the way. It's going to go crazy. And let's monitor it. So it's going to get all the repositories to start, but this thing is going to start flowing. There's going to be a ton of them if nothing breaks. We can see here that it's running.
Like the if nothing breaks.
Yeah, because as soon as we get all the repositories and we're starting to queue all of them, like we're going to get, he's starting this, like all this is starting all at the same time. So those are all queues. So in the background, what's happening? Azure Function is putting a whole bunch of objects in the queues, in the storage queues. And the same process, the same triggers that are used in Azure Functions are being automatically processed. And they're all there. Yes, my laptop is going to melt, Mr. Smoofy. And that's all because of you, because you did the HTTP start. And so all those queues are being automatically processed, and the result is being returned automatically to a blob or a table storage. And in the end, when all of those messages have been processed, and only then will we have the whole result, the whole execution, and we will have the result that was going to be returned. And you don't have to do any of that plumbing. That's the beauty of this tool. And we have not talked a single time about queues. We have not talked a single time about the storage, the blob, or those kind of thing. And it just works. And I can still do refresh. And by the way, I'm expecting this thing to break at some point due to GitHub API limitations. Like I'm going to break some limits at some point. So yeah, the laptop may melt. I have no clue if this thing is going to keep running. We're going to keep this thing up. But now imagine that you're running this on the cloud, right? You're running this on the cloud, and my machine cannot scale. All right, it's a single machine. I don't have any ways to scale this. But if you're on the cloud, if you're queuing 1,000 messages, Azure Function is going to add the server, and then more and more and more until the queues start to be under control. And as soon as this queue is under control, it's going to start scaling down. And you're not paying for the servers. You're only paying for the execution. So if you have 1 million of those things, you may burn through your 1 million execution in a month, but 1 million execution is just a few cents anyway. So whatever.
Not that big of a bill. I mean, yes, it is a lot of servers, but at the end, they won't run forever. Like, you know, you're trying to process everything in a shorter time. So
yeah. So instead of going like bigger machine, like of scaling up, you're going like scaling out. Let's use more machines. And right now, my machine is like it's buckling under the load. I'm pretty sure of it. Like you're seeing this stuff is like updating slower now, but it's still processing.
It's already amazing that you can run all that from I know you have like a developer laptop, but still, like it's a laptop. Like we didn't deploy in Azure just to save time deploying and all those things. Obviously, that code means to be in the cloud, right?
Yep.
And it's cool that even like, you can debug, you can process locally, and that's nice.
Yeah, and basically, by the way, right now I could put any breakpoint and we would see the execution of that function. We would see it live. I would love to see this thing finish running before like Christmas is over, because it's a single machine. But imagine now you're running this on your start to scale up. I have a slide somewhere where I basically say where I messed up, and you see like in the Azure Application Insights, like you see the amount of requests Azure is processing, and the numbers was around 200 per second. And the thing is, it started using 146 servers, and I don't think I blew through $5 of compute. It was crazy. It was literally mind-blowing experience where I broke it. Like I misused this tool so badly that at some point it would have like frustrated me in terms of money it spent, but it didn't, because it's serverless. So the costs are very low. Of course, you're not running on like 16 core machine with 20 terabyte of RAM or something like that, but you're running 146 machines. And the only thing you wrote, right, is this. All of this is like in a single file. And that is the main organizer of this thing. Like the organizer of this magic that's happening in the back is this. And we're still getting get older issues that are running. It's still amazing. I don't know how long it's going to take, by the way. So I have no clue how many. But you know what? Let's just do a small breakpoint and see like how many repositories we're dealing with, right? So let's do breakpoint right around 64. And we're going to restart it right after.
And you can control also, by the way, like how much big you scale, right? Yeah, you have some limits. You can.
I think you could put some quotas that in terms of like I don't want to exceed that amount in a day or in a month.
Because maybe your processing task and like it doesn't need to be done like as soon as possible, but I would like to have it today.
Right.
So you could say, okay, scale up to whatever. There's some limit where you could play with that. Like, and I'm thinking on that because, like in the real world, like I see Mr. Spoofy and Talk to Me Gooseman talking about money and budget.
Yeah.
Like we all have a budget. So at one point you say, yeah, like scale, but like say in a reasonable, like something reasonable for my pocket, right? So there's a way to put some limits.
Yes. We could, let me remove the breakpoint so that I'm not stopping the process. Let's look for Azure Functions. I think it's quotas that you can do. Because there's a term that is called denial of wallet that is being used. That's been used in the past, where basically you're running a function. If you can know that an API is running behind a serverless platform, you can basically start hammering that one until there was no more money in the account. And you're not using it. It's just like very malicious way of doing it. Yeah, you can do quotas, but I know I have an Azure function somewhere, so I'm going to go in the portal. I'm going to pick one of my function, and I'm going to show you like directly in the portal what is going on here. There's nothing really. Yeah, this one is good enough. Oops, no, yeah, this one is. I deleted it. Sorry. Let's do Azure Functions. Let's do Azure Functions.
Jeff showed that feature, or maybe was it in preview? No.
Maybe.
A little while ago. Or was it on? Oh, maybe it was a Logic app. A Logic app also, you can do the same kind of thing where you could decide how many instances you want.
Yeah, maybe.
They are part of serverless, so like, and they are very. The pattern is a little bit similar to Azure, the durable function.
Yeah, I'm gonna go and show you the exact things I was talking about in terms of prices. I think I don't remember exactly where I saw it, but I definitely saw it.
Your stuff is still running in the background, Max?
It's still running.
Okay.
So I should have deployed that to Azure at some point.
Maybe
that would have been better.
We'll need to have you back, and then we'll be able to optimize and everything.
Yeah, 3 weeks from now.
It's 5 minutes now.
Is it done now? No, it's still running. Let me see if I can find out exactly where we are. There's quotas here. App service plans, quotas, and let me see. You can have threshold. You can see the thing that are being there. So see app service plan. I don't remember exactly where it is. But yeah, there's a way to set the limit on it. I don't quite remember exactly where it is. Yeah, it's story of my life, man.
No, I'm laughing because it says it will complete in season 2.
Okay, rule 1. Monitor the chat because people are being like way more what's the term, yeah, they were being skating a little bit about the performance of my machine, which is, yeah, I'm sorry about that.
It's fine. It's from a laptop. Come on.
Yeah, it is literally a laptop. Let's see if this still running.
The full purpose of that stream, in fact, it was just to burn the Max laptop because he wants a new one. That's it. That's the only goal. Like he asked his manager. The manager said no, so he called me, Frank, can I go on your show? I will kill my machine, and then I will have a new one. Hopefully, managers are not watching the stream. It's not true. Just making all.
Yeah. Yeah, so I'm gonna keep exploring this like while we chat. But this thing is
Mac. No, it's on Windows.
It's a Surface Book.
It's a good machine though, but like you're just asking a lot right now, and you're streaming.
Yeah, exactly. So let me see if I can look at the emulator and see if we have things. So you can see here that we have our all of our stuff is running at the same time, right? You have all of our different containers. You can see like the named instances of all of our let me see if it's I'm hoping that I'm not getting this thing dead, but you will see here all the execution that we did in the past. So you see like the owner, the result, those are the input, the output that were returned, those are the things we're running. That's what I mean here, right? Like the runtime status running. Do you see the ID here that says I think it's 140? And if we're going into our browser, instance ID FF870, that's the partition key here, right? So what we're having here is our execution that is .NET right here. We have it here. It's basically all it's doing. It's just reusing the storage account in a more, in a very smart way. And the thing is, first, this is running locally on a SQL, like, what is the small SQL instance running on my machine because it's an emulator, it's not the real stuff. So on Azure, the storage would be better, the machines would be better, there would be more machines. This thing would just fly. And what I basically did here is that I'm running like thousands of requests in parallel on a single machine that will never scale. And
so Max, I have no choice.
Cut me off.
We'll force to have you back on the show, and this time we'll start with a durable function working, and then we'll optimize it, maybe deploy it, or like see the other end of that story, because it is really interesting and it's so powerful.
Yeah, it is.
So so I know you had a bunch of links. I didn't put everything in the chat. After the stream is done, I will put it inside the description. Once the video is uploaded to YouTube, every links will be available also in the description on YouTube. But where people can find you if they have questions, because I'm sure a lot of people have questions right now.
You can find me on Twitter. You can find me on LinkedIn. I can try to paste in my email address, but I don't think I'm going to do that on chat. If you go on aka.ms/maxcda,
let me
maxcda, like if you do aka.ms/this in the chat.
You know what? That I can do. I will give 3 links. Boom. So now we have your Twitter. We have your bio on the CDA webpage. So over there, there's all the others way to
Awesome.
Connect Max. And you see also his GitHub, where Max is sharing a lot of content about durable function and many different things.
I'm doing a lot of samples, and those things are always good. So yeah, I don't think that thing is running finished running within the next 5 seconds. So I think we're done.
I think that's life.
Yeah, no jokes, man.
Dude,
all right.
Thank you a lot being with me today. It was awesome. By the way, chat, I asked very last minute to Max, hey Max, you want to come and show me durable function? It was all improvised. Max, you're awesome. Mr. Beast. That's a real alias on YouTube. But like, really interesting. I'm very serious having you back again on the show, continuing that story. So I think it will be awesome. I'm sure the chat is with me with that. And talking about the chat, thank you all for being with us today. It was really great. Thank you for your questions. Hit Max with questions on Twitter if you want. And yeah, Max, the word of the end.
That we did not coordinate our glasses, that's for sure. But please, if you're on Twitter at the same time, please follow up on the Azure Functions. And if you have not done the learn path on docs.microsoft.com/learn, I would highly recommend that you do it for an introduction to serverless. What we presented today was more than level 100, but it was way more fun than just level 100 stuff. But I would highly recommend that you do those learning paths, because they will really get your level of understanding high enough that you're going to be able to grasp this stuff and be as excited as I am over durable functions that you should all be. So, when can we expect another stream? You have the question here.
Oh, when can we another stream? I can book until end of July. The show is booked, but I will try to squeeze Max somewhere. So we'll let you know. So follow us on Twitter. We'll make noise about it. That's for sure.
Yep.
Thank you all again. See you next time. Bye bye.